Yeah, good afternoon, everyone, and thank you so much for joining us today. And apologies for the inconveniences. We know we shouldn't have postponed it, but we had to just do that. So thank you so much once again for joining us today. And so on today's topic is going to be live coding session by our amazing tutor, Soji Egbon, team lead, senior software developer at Vogue, Canada. So he'll be the one that is going to be taking us today. So this is week 11, and next week is going to be the final week. And so I hope you guys are going to enjoy today's class. And yeah, so I've been handing over to him not to waste so much time. Yeah, thank you. See you guys soon.
Okay, thank you very much, Shi, for the introduction. And I must sincerely apologize to everyone for the inconvenience of today, of having this today, and also for the inconvenience of the schedule. Sunday probably is not a good time for programming, right? Especially Sunday evenings for you, for everyone in Nigeria, and Sunday morning for me over here. So really sorry. It was actually because there was absolutely no other option. All attempts to reschedule my clashing appointment for yesterday failed. Okay. I can't apologize enough for that. Okay. And I don't take it for granted that you people have to sacrifice to be here. Let me share my screen. We are going to do something slightly different today. I don't know how many of you will be able to participate. I'm just checking out to see turnout. Yeah, turnout is very, very low. So I would have loved this to be very much more interactive. Let me share my screen. Okay, there goes my screen. Okay. Okay, even though we have low turnout, I will encourage everyone here to participate in what we are going to do today. Essentially, we are going to be looking at certain practice questions, and together we'll walk through the process of answering those questions. So that process involves breaking down the problem, reading the question, understanding it, breaking it down, identifying the facts or the important points in the question, coming up with an approach to solving it. Oh, okay. So there are 4 questions, okay, which are in the table of questions, in the table of contents here. Those questions we will, I think for the first one, we'll look at the first one together. All right, so I'm going to be sharing another screen shortly. For this practice, also, I decided to use Akarank for the practice questions. So I'm going to be picking a question from Akarank. Just stay with me. Let me bring up the screen, the Akarank screen, so it's better over there. How do I okay. Okay. Okay, so we have the first question is here. Okay, repeated string. Now, if you are able to open your system, your development environment, either Visual Studio Code or whatever language, whatever ID you use. Let's look at these questions together. It's called repeated string. Okay, it's hacker rank. I just logged in there and pick a random question, or it showed a random question for me. Probably in the next meeting next week, I will talk more about practicing certain questions on hacker rank or whatever online programming practice site you use. There are a couple of them. If we look at this question, we let me see, magnify, make sure it's bigger. Okay. All right. So if you look at the question, there's a string S of lowercase English letters that is repeated infinitely many times. Given an integer n, find and print the number of letter A's in the first n letters of the infinite string. So that's the question. The first way, usually you may have to read this question 3 times, 4 times, maybe 6 or 10 times, just to make sure you understand what is required. So there's a string S of lowercase English letters that is repeated infinitely many times. Given an integer n, find and print the number of letter A's in the first n letters of the infinite string. So having read that, then you begin to see further details about the question. So you'll be given, you have example, this is the S string, something like this, ABC, AC. The integer value is 10. So the structure we consider, they describe it just to give you further context and details about the question. The structure we consider for this particular example is ABC, AC, ABC, AC, the first 10 characters of the infinite string. Okay, so there are 4 occurrences of A in the substring. 1, 2, 3, 4. Then further description about the function where you're going to write your code. Yeah. Complete the repeated string function in the editor below. Repeated string has the following 4 parameters. So you'll be given all these details. What your function must output at the end. Frequency int should be a data type of integer, which is the frequency of A, the number of A in the substring that you consider. Right. So the first line contains a single string S. The second line contains an integer n. All right. You just need to pay attention to this. Right. Then you look at the constraints. you'll be given different sample input. So if you have a sample input of A, B, A, and the total number of strings you should consider, because remember, this string is going to be repeated infinite amount of times, okay, to infinity, actually. But you're only considering the first 10 characters and then counting the number of A in first 10 characters. So if you repeat that number of times, there will be 7 A's in it. So the first n equals to 10 letters of the infinite string, which is this, okay? ABA, 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 then extra A. So this is 10. We ignore whatever comes after. From the 11th character to infinity is ignored. Because there are 7 A's, we return 7. If you have this kind of example also, you could be given an input like this. So you have just one string, A, and you are supposed to get this amount of A's if you are to repeat this. So this is how many zeros do we have here? That's 1 million. 1 trillion. Okay. Okay, so we've got 1 trillion. Let's say we have 1 trillion here. This is 1 trillion. So you have to get A's to the in the first, the A's in the 1 trillion text, where A is repeated in this case 1 trillion time. This is tricky. Okay, the answer for this will still be 1 trillion. Okay, because the explanation is that because all of the first n, all of the 1 trillion characters of the infinite string will still be A. So you just return the same number. Okay, so before we go look at the solution, I want to hear from you. I want you to look at it again and then try. Don't bother about whether you don't think about it, don't feel uncomfortable. Okay, just try to make sense of it and then bring up your observations. Okay, bring up observations. What do you observe about this? What do you think about it? Okay, if you feel something is not clear about the question, also bring it up. You can either type your question or your observation in the chat. Okay, so what do you observe? The first thing is that what do you observe in this question? How will you go about thinking about it? Okay, so feel free. You can chat, you can type your message in, or maybe if you want to even ask a question on this, you could bring it up. Just you could ask. Yeah, you can unmute yourself and then ask. So my question again would be, how will you go about this? How do you understand these questions? What do you observe? What are your observations, essentially, about it? Okay, so We won't take much time about it. I'm going to point out, if there's none, I'm going to point out certain observations. So let me go back to my slide, and then I will project it. I'll project the same question on my slide. Okay. So what we have here is just the same question. Yeah, it's just the same question that we read over there. Yeah. So what are your observations? What do you think? In looking at a question like this, bear in mind some of the things we have said about data structure and all. Okay. This one is simple. You may not directly.
Please, could you zoom in?
Okay.
The text is small.
Okay. Let's see.
I think it's a nice slideshow.
Okay. Yeah, because it's slideshow. Yeah, let me find a way to zoom in. Let's see. Let me see if it can. Oops, no. Attempt to zoom in, even reduce it further. Is it better at all?
It's a bit better, but I think it can be better still.
Okay, I think this is as far as it could go here. Yeah, because it's share screen. That is why it's not showing properly. Oh, okay. Hold on. Let's see. Okay. So please just try. Should I increase this? Okay. Yeah, maybe. Yeah. Okay. Okay. Maybe a bit manageable. Yeah. Okay. So sorry for the inconvenience. So what to look at? I'll just point out these observations. Okay. In looking at programming questions or in thinking about solutions to problem, look for the cogent point, the important points there in the question we just read. Okay. Remember, the text is going to be repeated infinite times. All right. So you have something like, let me. Let's see. So you have something like A, B, C, A, C, which is the text you are given. And you're going to repeat it infinite amount of times. So you could go without any space. There's no space in between the two. So A, B, C, A, C, A, B, C, A, C, A, B, C, A, C, A, B, C, A, C. You keep going, okay, to infinity. Definitely, if you want to keep going to infinity, you're going to run into a problem. Stack overflow there's not enough memory or computing power to take or process infinite amount of text, okay, in the current computing system we have. So we can't take infinite amount of text. So generating the actual text itself in this case is a no-no. It's a no-no because first, there's no computing resource for that operation. And also because you have been given an integer n, and the amount of text in the infinite text that you should consider, that you should limit your solution to. So even though we have infinite amount of text, we only need to consider substring of n. In this case, if you are doing 10, we're saying 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So everything after this, we ignore. So generating the text is inconsequential. Avoid it. All right. And it's the same advice is relevant for any programming challenge, whether in your current work or in any programming test. Avoid non-essential operation, because at best, that operation will increase either your time complexity or your space complexity. Okay, something will be impacted. Just that operation x plus y equals to z, no matter how it is, if it's not necessary, don't consider it. Don't use it. So the second observation is that in the text, pay attention to the constraints. Okay. In your programming challenges, you always see, you always see constraints. Oops, I can't go back. I can't undo it. You always see constraints that are mentioned. Oh, okay. So you want to make sure you pay attention to the constraint, especially to know this. What is going to be the upper bound of data given to your function or your operation? So that's the maximum input, the maximum data size. Okay, in this case, we've been told that the n given will not be more than 10 raised to power 12, which is a very large number. Okay, it's a very large number. So in this, for one of the examples, if you remember, in one of the examples, we were given just, we're given a possibility that you could have a string S, a string A, and you have to return how many? I think 1 trillion. 1 trillion A. Okay, that's a big number. Okay, that's a very big number. What's the maximum size of characters your computing can take currently? Who can answer that? Who can answer that? Hmm? Okay, someone raising, I just saw now that someone is raising his hand.
So please the question.
Pardon? I didn't get that.
Sorry, sir, the question again.
Okay, yes. So I'm asking that, what is the maximum data size of a text variable in any language or in your language? The maximum size. a text variable, like your string variable. If you declare a variable, let's say string x equals to this, what's the maximum amount of characters you can have? Who knows that? Who wants to answer that? No, no attempt. Okay. I'm seeing some 2 raised to power 64 minus 1.
So 250.
Okay. 256. 250. Okay. Okay. So in terms of it is large. Okay. If you look at it in terms of the number of characters, I'm looking at the number of characters. If you say 2 raised to power 64, yes, is still very large. Okay. It's a very, very large. It's a large data set that you really don't want to consider storing or bothering about. It doesn't make sense to even generate 1 trillion. It doesn't make sense to generate even 1 million. Let's even come down 1 million characters. Okay, it doesn't. Okay, is again going to slow your operation running time. And remember, there's always a time limit. Okay, so you want to make sure if you see this maximum size, yes, any size at all, as much as possible, even if it's 100, 1,000, as much as possible, avoid doing any computation, any operation that would require generating that amount of text, whether it's characters, like string characters, or even numbers. Yeah. And another thing you were told in that is that 25% of the test case, because there are going to be various test cases executed against your logic, against your program. So 25% of the test case, we are told, will be less than or equal to, or will not be more than 10 raised to power 6, which would be which would be large also. Okay, 10 exponential 6 will be what now? Okay. So 25% of the test case, we are told they are going to demand like 1 million. Okay. They're going to demand 1 million. You are going to have to check 1 million characters, 25% of that. So it means 75% will be considering more than 1 million text. And you don't want to generate that also. Okay. So the approach used, let me go back to HackerRank. So the approach used is this. Okay. So the approach used is this. Okay. So doing this in, I need to bring this down a bit. Okay. Okay. So here's the program, my solution in JavaScript, okay, which is this. Okay, so you're going to be given an empty function. That's why I didn't bother writing it elsewhere. I just wrote it here. I'm given an empty function. So this is the program I wrote. Okay, I don't have to bother with formatting and passing the input. Okay, so I focus on the solution here, which is what you'll be doing in most of the practice sites or the programming test sites. You just focus on your solution, not the logistics. Right? So here's the approach. Oh, okay. The first thing I did is this: get the number of A in the string itself. Okay, this is syntax function to do. I just try to avoid an iteration here, but of course there's still an iteration under the hood of this filter function of JavaScript. So I'm using this as a way to say, okay, given the from my variable, I first count the number of A I have in the variable. How many are they? That's what I store in first count. Oh, okay. So what this means is that if S is whatever S is ABC, AC, okay, if first get the first count, how many A's are in this? There are just 2. Okay, so you have 2 here. Then this is very important. The next thing I did here is to check that is the number of A equals to the length of our variable. Okay. If it's the same thing, then return just N. Why is this necessary? Who can say why this is necessary?
That means almost everything are A.
Good.
Everything are A.
Yes, everything is just A. All right. So for some of those tricky questions where you're asked to return 1 million, to consider 1 million substring of text, and you are given A, we don't have to do this expensive logic. Whatever logic comes, we don't have to. Okay. So this is where that check is important. That check helps you get to the answer as fast as possible. Okay. If it's nothing, then we can be, if this condition is false, then we are sure that there are other texts, because if this is AA and we are returning whatever number we are returning, we just return all of them are A. All right. So, but if it's in this case, if it's ABC, AC, all right. So what do you want to do? Here, what I did was to get a remainder, okay, divide N, okay, the number of text we should consider, get the remainder when we divide it by S, okay. So then the next thing we'll have to do is determine number of times to repeat S without any remainder. Okay, what number of times do we need to repeat S? How many times do we need to repeat it? So in this case, if N is ABCAC, what is N? Is it 10? Okay, so if it is 10, if it is 10, yes, so this will be 10 divided by what is S length in this case? 5. N divided by 5, that is 2. So number here is, the non-variable here is 2. Okay, then what do we have to do after that? We have to now get in case there is I call it here like remnant text. Okay, the many text we have to get. So here we now say S, okay, get substring of the whatever is remaining from it. Once we get it, the next thing we have to do is then say, we count again if there is still any A in the remnant text. If then in some cases, there will be no remnant, but in some there will be. So we get the remnant text, and we count the number of A in the remnant text again with our filter function. And then what do I do here? This is where I then compute the number of A. Now, for line 49 and 50, I put this here for my own testing, just to see the data for small amount of N. I will probably just show this, so that if we say I say here that let result be S repeat it. I'm repeating it in this case. I'm repeating this number of times. This is not necessary. Okay, it will increase my time complexity. That's why I remove it. But for my own testing, just to see how the data works, I put it there. All right, just to view it. Then I get it. Let me see. If am I not putting it? Okay. Log it. That's a result. Okay, so I just output it to see, okay, for this, in this case, this ABA, to see all the text generated. For simple case, it's okay, but for long case, not okay. All right. So you can see for this case of A, and I'm to consider 1 million, there's no need to do that, because the condition here already help us avoid that long computation. Okay. But in this case, I only just output to see what it is like, the text I'm considering. So for ABA, let's go to ABA. For ABA, where I'm to consider 10. So if I say this is the 10th substring that was considered, okay, this is what it was considered. The first thing I did was to count the number of A in this character, in this S, which is 2. All right, I got 2 there. Then divide N by S. So 10 divided by 3 will give you 3. Okay, but here we already have remainder, because the modulo N by S will be 1. So we have 1 here. Here we have this 1. This gives us 1. Norm here gives us 3. Okay. Then here, when I do remainder, what is remaining, if I'm to get from S, I'm to get, in this case, what this will give me the remaining number in S that I need to get. Maybe in this case, because we have, if you look at it here, we have 3. We are going to 10, but this gives us 3. So 3 times 3, 9, remaining 1, which is the one we have here. Then it means that we need 1 extra character in our base string. Our base string is S here, 1 extra character, which is what I'm getting here. I only just pick the first one. So in some cases, it could be 1, it could be 2, depending on the number of characters. So I'm only getting 1 more character to make up 10, because this will give me 9 characters. Num times 3 will give me 9 characters. Okay, to make it up to 10, I do this. Okay, so this will give me the first character in ABA, which will be A. That is why I have this. Okay, and where that was done is, where is it? So if I repeat this number of times, if I say I call this function to repeat S 3 times, in this case, it will be repeat S 3 times, so which should be ABA, 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 remaining 1. Then the remaining character, I just pad it. Okay, I just pad it. So I could also have done here, because I commented it out, I could just pad it and say use remnant text here. Okay. Remnant text, then this just to see it. So how do I eventually know how many characters are there without doing an iteration, going through the text again one by one? So this is where I just use a mathematical function. Just the first count, which is the first number of A in the base string, multiply it by the number of times we have to divide the number of times we have to repeat the text. Then the next thing is we then add the number of A in the remaining text. That way we get the frequency. So if this is executed against, I don't want to do this. If this is executed against many test cases, both known and unknown, I'm able only to see 2 test cases. Okay, so for the other test cases, you can see they are locked. I can't see them 22. There are 22 in all. I can only see 2. Yeah. But I know that 75% of these test cases are more than 1 million, require processing more than 1 million text. Okay, so this works effectively. Okay, just by paying attention to the data and then finding a way to avoid counting. So the only operations we only did once. Here we loop, there's a loop here. Whether you use an iteration or you use a filter function, there's still a loop under the hood here. Okay, so this is just a convenience method. So we have a loop here, which will be a linear. It will run through everything, a linear runtime. Okay, then we have another run here. So we have n number of operations here. This will be n divided by 2 as a maximum. It could be less than that, it could be 1, but as a maximum. Okay, so irrespective of the large data set, this is going to be efficient. Okay, this is going to be efficient without doing any repetition. So again, if you go back to the question, okay, looking at it, you have to process text that is repeated infinite times. with focus only on a subset denoted by N. Okay. And how we go about it is simply finding a way to avoid repeating the text during the counting and then processing limited text. Okay. Maybe for your information, how long did it take me to come up with this solution? Took me about because it didn't run, it failed against some test cases the first 3 or 4 times I ran it. Okay, so I had to make modifications, check my logic here and there. So it required, I think I would say I got it right, actually, like all tests passed after the 6th run. Okay, 6th run. The last thing that put me off guard was using this function. This is very important. Math.floor. Okay, in case of what do you call it? A fractional digit. In case this division, the division here, okay, I also wrap this in the math.floor so that it bounces away all the extra data, the decimal, the fractional aspects of the data. So here, n divided by x, instead of it giving me 4.3, okay, which will skew my computation here. Okay, so at that period, I get only the maximum on the whole integer, in this case, 3, not 3 point whatever. Okay, because that will skew your result and it will fail. So this was the last thing that tripped me. Okay, so the takeaway from that is that really you want to run the data, run your program, you want to test it to make sure that it works. So after the 6th run, all the tests passed.
Sorry, can I ask a question?
Yeah, go ahead.
If you're doing math.floor on 45, I'm struggling to realize why the one on line 52 is necessary.
Okay, let me see. Line, wait, let me share my screen. Line 50 what?
52.
Okay, line 52. Okay, yes. So why is it necessary? Let's see. Okay, so first count will definitely give us a whole integer. Okay, then num will give us, yes, none already removed that. So this one is actually not necessary. Okay, so maybe this is me just being pessimistic.
Okay, thank you.
All right, yes. So it's not necessary because I've captured it, I've removed that possibility here. Okay, so thanks for that observation. So this is what happened. I think the last one, when I ran it and I came across that problem, I wrapped it. I think maybe I solved it here first. It skewed my result here first. Then I wrapped it here too, just to make sure. Yeah. So thanks for that observation. Okay. So let's quickly move forward. Any other question on this?
Please, I didn't get the explanation that you gave about what we should do with the unique constraints that are provided.
Okay. So the unique constraint, the constraints usually in your question, in any question you are given, what the constraints will point out is to guide you on, or to let you know the worst case scenarios in terms of the maximum input, the maximum data size that will be fed into your program. It is different for each question. Okay, paying attention to that helps you come up with a solution that addresses that particular problem, because you could make an assumption based on, say, 500 data size, and then forgetting that you actually should pay attention, you actually should expect 1 billion. Okay, so paying attention to that concept, the constraint section of your question, we highlight that. In this case, it lets us know that, hey, be careful. We can give you a curveball. We can give you such a huge data size that your program will either crash or just say, hey, I'm fine. I can handle this. Okay, they want a solution to be able to handle it. Okay. In our own case, if we didn't consider that, if we had not considered that, we wouldn't have put in that check. All right, we wouldn't have put in that check to check if the number of A in our base string is equal to the number of substring we are to analyze. Okay, so we just check it to avoid unnecessary computation and quickly come up with the answer. So the constraint section will always bring up that the way we have it in this. So here in this same question also, we have such constraints. This constraint, pay attention in this case, I've not read this question, but in this case, is saying your Q will not be less than 1, but will be less than or equal to 100. Okay, your Q is less than 1, your Q is less than or equals to 100, but cannot be less than 1. And then you're also giving XYZ the range of data to expect in there. So the constraint section, pay attention to it. In the other case, we were told that 25% of our test cases will handle very large data, more than 1, is it 1 trillion? More than 1 trillion or more than 1 million. So we have to bear that in mind. Here. So there's another one to consider. Quickly, let me see. We still have time. Okay, we'll just consider this one quickly. I don't know if this is friendly to the eyes, if you can see this well. Hold on, let me see if I can find this here. Okay, yeah, okay, I think I should have it. Yeah, so let me share my other screen. Okay, so picking numbers, yes, right. So there's a bit tricky also, right? If you look at this one, given an array of integers, find the longest sub-array where the absolute difference between any two elements is less than or equal to 1. Yeah. So an example would be something like this. This is an array. You are 1 1 2 2 4 4 5 5 5. All right. So there are two sub-arrays meeting the criterion. In this case, 1 1 2 2 as a segment. Then you have another segment 4 4 5 5 5. The maximum length sub-array has 5 elements, which is this. Okay, this is the maximum length here. So the reason for this, why the two segments here is that 1 minus 1, 0. 1 minus 2 or 2 minus 1, we get 1. 2 minus 2, 0. So the maximum difference, okay, where the absolute difference, yes, the absolute here is important because in case of 1 minus 2, you have minus 1, but in this case, we are considering the absolute difference is less than or equals to 1. So minus 1 is okay, or you wrap it up, throw away the negative symbol, and you have 1. That's still okay. So the difference among these elements here is less than or equals to 1. So is this. If you have to do 4 minus 2 or 2 minus 4, you have 2. Okay, so we break them into 2. Then they go into describing the function description, describing the function, and the other condition, which is where you see the constraint, right? Now, in this case also, we are told that the answer will always be more than or equals to 2. Okay, just for you to note as you validate your answer before submitting it. Yeah. Then if you have sample size like this, you are given this number 465331. You'll be given an explanation where we choose the multi-set of integers from the arrays 433. Okay. Each pair in the multi-set has an absolute difference less than or equals to 1. So 4 minus 3 is 1. 3 minus 3, 0. So in this case, 433 is what was choosing. So we print the number choosing integer. So we print the number of choosing integers, 3 as our answer. Because again, 6 minus 5, here 6 and 5 will belong to the same group because the difference is 1. 4 minus 433 in one group, then 1 will be in its own group. Okay, so the sub array that has the highest amount of items will be the source string that contains 433. Okay, so it's the same with this also, where this one would be 1 2 2 1 2. 3 will be in its own array. So I will still leave this. Let me leave this on the screen while we talk about it. So again, what do you observe? What do you think about this? How do we go about solving it? Oh, okay. I think I showed you the third question instead of the second question. Oh, sorry for that. I showed the second. I was meant to show the second question, but I showed the third question. but we'll just quickly continue. I won't spend much time on this so that I can just go back to the second question then. What you want to do with this, in addition to what we have said about paying attention to the constraint, okay, you want to visualize the data, okay, yes, which is why usually you will see them break it into sections like this in the explanation, 1, 1, 2, 2. So you may have to do the same thing just to make sense of it, to understand it, okay? Then this is tricky. It's tricky because you may want to go through each record and perform long computations. I trade through all of them, take one question, take one item, and then begin to group based on difference with the other items. So is this something worthwhile? That's the question one will ask. That do I need to go through so many iterations to do this? The simple heuristics or rule of the thumb that I prefer is just minimize your iterations. They should be as small as possible, or at least on small data set, or not often. Okay, so if we just go back, because of time, I think we are running. Let me go back to my slide. Yes, so, okay, this is longest sub-array. Okay. The idea is, okay, if you look at it, you visualize, in visualizing the data structure, come up with a fitting method to group that data structure. And what I did in my own case is this. I'll just show this solution straight away. Okay, in picking this number, what I did is to use in this case, a map, a hash map in Java. This is the program in Java. Okay, so I just use a map data structure. Why did I use a map? The match is like a hash table, okay, which we talked about in one of our earlier sessions. Okay, that allows us to, you get a hash code, or rather, you compute a hash code for a given value and store it in a particular place. So in my own case, I just decided that, okay, let me create a group for each item. Okay, a group. So what I did in this case is to count how many times do we have a particular number. Sorry, let me reduce this. Okay, how many times do we have a particular number? Yeah, going back here. So in this case, I want to get a unique, I want to count the number of occurrences for each item. How many ones do we have? How many 2? How many 4? How many 5? That's why I created that hash table. So I know that I can only have one unique item, no duplicate in that case. So I'll have a table that has 1, 2, 4, 5. Did I put it in? Yeah, like this? So let me draw Let me draw it here. So I have a table that has 1, 2, 4, 5. And I count, okay, how many ones do I have? 1, 2 is 2, 4 is 2 is 2, 4, 2, okay, 5, 3. Okay. So I have 2 here, I have 2, 2, 3. Yeah. So coming up with this table is where I had is what I did with this iteration. Okay, so I find it much more convenient to just use JavaScript, Java there for this. Where, okay, now that I'm going to create a hash map, a table from which I'm going to derive this hash map. So I create this table structure, and then for each item, I go through all the items and say, okay, if this element already exists, that's what this helped me do. If this element already exists in my table, the first time it goes through it, it won't find anything. All right. And then if it doesn't find my norm, which in this case is the first time it goes through it, it will be, sorry, let me do it this way. Okay, so first time the table is empty. So when it gets to 1, it checks. Okay, if there's nothing there, if there's no 1, it puts 1 in my table and check it and say, put into this table 1, which is the variable here, and then check inside the same table. Do I already have this number in my table? If I already have this number in my table, do not add again, just increment it by 1, which is why I have +1 here. So the first time it will be 0. So 0 plus 1 will be 1. Because the data is 1, 1. So it gets to the second point, the second one. The second item is still 1. In this case, it will just increment this 2, because it gets the data that's already there and then add 1 to it. Then it goes to the third data, which is 2. Do I have 2 in this table? No. Add 2. 0 plus 1 will be 1. The fourth item is still 2. So because it's already there, that's how we got 2. Then 4, we got 4 is 2 also. Then 5 is also 5 is 3. So it doesn't matter the arrangement. The ordering here doesn't matter. It doesn't need to be sorted, okay, for this to work. I don't have to sort it. Maybe there's a way sorting it could help. It's possible also you could actually sort it and see what you get from that. I mean, I ran this, I used this approach I ran it for about, I think this one took me about 3 or something hours, no, thereabout. Okay, to just figure out that maybe I should do it the way. I tried other methods that I wasn't really satisfied with. Okay, so I have a table like this. If I have a table like this, okay, it means that I can begin to consider, I can begin to group them based on the difference with their neighbors. Okay, so if we look at this, the difference between this and this will be 1. So they will be in one group. The difference between this and this will be 1. Okay, which is what I did here. And based on that, I can now say, okay, if the difference between this and this is equal to 1 or less than 1, then all I need to do is just to count their maximum items. So we have here 4, 4, 5, 5, 5, which gives us 5 items in this group. Okay, so this is why this is the longest sub-array. Just looking at the difference between their index value, that the difference between 2 and this will belong to different group. So if we have, let's say, another number here, which is, let's say, 9, and 9 occurred, okay, 2 or 1 time, is still going to be this. All right. Okay. So even if 9 occurs 10 times, then it's going to be it's going to be 9. All right. In that case. So which is what I did here, that in getting the difference, I get the key. Okay, the key in this case is the index, is the indexer here, this number. Okay, get the key, get the current length. Okay, I store the current length as the value. So for 1, if I go through 1, how many occurrence of 1 do we have? 2. Okay, check if there's something, if it has a neighbor. In this case, num, if you go through 1, num is 1, num minus 1 will be 1 minus 1, 0. There's nothing above 1. Okay, so if there's something above 1, okay, check, get the value. Okay, so get the value of that, compare the maximum length. So this is what I now did here, that the maximum length at every time, at each operation, at each run of the operation, I'm checking the maximum length with the current length, with the current position I'm in, that, okay, is this maximum? Does this give me maximum? Does it give me maximum as I add it? If you add if I get what this has, 2 has 2, add it to what is neighbor, okay, that's less than 1 has. If this gives us maximum, we return this. If not, we check again. By the time it's processing for 4, the maximum length will still be 4, because so far this is the maximum. But when it gets to 5, when you add this with its neighbor, which is less than 1, then you get 5. If there is 9 and 9 only has just 1 item, that means that this length, which is the current length, is still no more than the maximum length so far, which is this. So, okay, so that is the method of solving this. Okay, so next week I will still talk more about why we need to go through this again and again, and I don't want to say some of those things now here, but generally that is the approach. The approach is first putting this in this is the most important thing here. The most important thing here is actually this: finding a data structure to just group them first. In my own case, okay, group them first, and then based on that grouping, go through the iteration. Okay, check with their neighbor which one is more or less. Yeah. Quickly, let's go to this, because I actually wanted to point out something here also, because of time. I thought it would be faster. I thought I'd be faster. I didn't know it would take much more time to go through it this way. Okay. Let me see. I just want to make this bigger because of time. Visible. This is an interesting story, but because of time, I'm not sure we'll be able to go through it so much. But I will just read this quickly and then point out the observation. We probably, is part of what we will still discuss with the organizers. After this session, we probably need to have maybe a monthly maybe a monthly session. We take just one question because of time, really. We'll take only one question and then solve it together. A live question, maybe on Hackathon, NEET code or LEET code, and then solve together. We may be able to finish it in a session, maybe in a 1 hour session, or we may not. We move it to the next session. But we need to have something like this to just keep the flame and the support ongoing. So I'll just quickly read this. 2 cats and a mouse at various positions on a line. You'll be given starting positions. You'll be given starting positions. You'll be given their starting positions. Your task is to determine which cat will reach the mouse first. Assuming the mouse does not move and the cats travel at equal speed. If the cats arrive at the same time, the mouse will be allowed to move and it will escape while they fight. You are given few queries in the form of extra. They go into the data structure and all, and then the condition. If cat A catches the mouse first, print cat A. If cat B catches the mouse first, print cat B. If both cats reach the mouse at the same time, print mouse C as the 2 cats fight and the mouse escapes. They were given all these conditions. S equals to 2, which is cat A, cat B is Y, 5, and then Z, which is mouse, 4. The cats are at position 2, cat A, 5, cat B, and the mouse at position 4. Cat B at position 5 will arrive first. Since it is only 1 unit away, while the other is 2 units away, so in this case, we'll return cat B. All right. This is just one funny or interesting story. But the thing you have to note about this, quick observation about this, is just look beyond the Nollywood story, okay, beyond the movie. Just get the underlying facts. Okay. The important things here are actually the values, what you are given here. Okay. And then from this section to this section, okay, get those facts in numerical terms. Okay. Then you are also given something interesting here. I think I should show that one to you. Yes. So this is, in some questions, you'll find this very helpful. In fact, most questions will, as much as possible, give you good enough information to solve it, because the goal of the problem usually is to make sure you are able to solve it. So there's usually less ambiguity. But I like the fact that they give you this visual aid. Okay. So they explain it in this way, using a number line. Okay. So you have cat A on this number line of at position 1, cat B at position 2. the mouse at position 3. And then, so when you look at it this way, it just helps with how you go about coming up with the solution. So whatever happens, whatever details in the story, you just know that card B will reach here first. Okay, so ignore those details. If you look at this, card B will reach it first. Okay, in this case, where is card? So if you look at this line, card B, query 1 in this case. Now, for the mouse C, in this case, this should be mouse C. Card A is in 1, card B is in 2, and mouse is in the middle. So in this case, the condition is that if they both arrive at the same time, the mouse escapes. So here the mouse will escape, will print mouse C. Okay. So if you have a question like this, think, okay, use the linear structure. Even if you don't have that structure like this, try to visualize the story you read here. They already told you 2 cards and a mouse are at various positions on a line. So that phrase on a line is an important part of the statement. Okay, so you could represent it this way, and that ultimately guides you towards a solution. And the solution is simple. Okay, because there's already a number line. The number line points you to the fact that, okay, you just need to get distance. What's the distance of X to Z? This mouse A. How long will it take mouse A to get to cat A to get to mouse C? How long will it take cat B to get to mouse C? So you check their absolute distance. Again, it doesn't matter. The symbol on the figure doesn't matter. Okay, so it doesn't matter whether it's you're moving backward or forward. It doesn't matter. That's why we use an absolute function here. Okay, so we get distance of A, distance of B, and then compare. It's just simple comparison. If distance of A is less than distance of B, we'll return A. Otherwise, we'll return B. If both of them arrive at the same time, we'll return C. Okay, this also underlines a fundamental concept in computing or programming, is that most things, in fact, nearly all things are arrived at arithmetically. Okay, with maths, you solve a whole lot of problems. The stories, as dramatic as this story is just solved with simple math functions or math operations of addition, in this case, subtraction, and then comparison. Okay, so distance from one place to another, and then compare the distance you return. So it's just that simple. Okay. When we talk next week, the last one, because of time, I won't go into the last question today. Really, 1 hour 30 minutes, everyone will be mentally fatigued. Also being a Sunday. Okay, but this is what we'll come across in most of the questions online and in practice situations, that usually as you visualize your data, okay, you visualize the data. Once you come up with a structure like this, you just hand it over to mathematical functions or equations, and you get to the answer. All right. So please, I will just stop here today. The last one I had was I wanted to use this money change problem to illustrate dynamic programming as was discussed last week. Okay, I will just include it in the slide. We won't have time to go through it today. I planned to go through it with illustrations, but I'm not sure I did a good job of time management today. Okay, so there won't be exercise today. I'm going to discuss with my co-facilitator the questions, when to send out the questions that will be used for the competition. And I'm also going to discuss with the facilitators, the organizers, Sheyi and his team, on how to coordinate the competition. Okay, so there won't be any exercise for today. We will discuss among ourselves, organizers and facilitators, with the next step, what we should do on the next step. Okay, so that will be all for today. Is there any question before we wrap up? Any questions? If no question, Sheyi, you can have the floor. Thank you.
All right, thank you so much. We really appreciate your time today. And, yeah, thank you so much, everyone, for joining us today. As he has mentioned, we will get back to everyone on what we communicate to everyone on what you guys should know before next week, and pressure for next week class, which is going to be the final class for this bootcamp session. So thank you so much once again for everyone. We are going to share the recordings later for you guys to go through it again. And yeah, thank you. Have a great evening. Bye, everyone.